Hello, welcome to Enlightning. Thank you so much for spending your time with us today. Today we're going to focus on learning Project Notary. We have a couple maintainers here with us, Milind and Toddy. Will y'all introduce yourselves, please?
Hi, Whitney. Milind here. Happy to be here and talk with everyone about Notary Project. I'm a maintainer on the Notary Project and also a senior developer on AWS Signer, which is a code signing service. I've been in software development around 20 years, worked on application development for almost half my career, and then kind of developing platform frameworks, etc., with AWS. And
Awesome.
so I have a viewpoint of like both of the sides as a consumer and a creator of software products.
Love it. Tell us about yourself, Toddy.
Hi, Whitney. Thanks. So I'm Toli Mladenov. I am a principal product manager at the Azure Containers team in Microsoft. I've been actually similar experience as Milind, so I have 25 years experience, if not more. Half of that time I spent as a developer. I developed applications, various applications. Other half mainly as a product manager or architect. I did a lot of consulting work for various companies, mainly working with Azure, AWS, a little bit with Google Cloud. So I was on the early Azure team when it started in 2009. I've been maintainer on Notary Project for almost a year. So I kind of became a maintainer last November. And since then, actually, it's been great collaboration with the community and working with Milind and folks from AWS and Docker and other companies that participate. So nice seeing you here.
So impressive. I'm relatively new. I used to be like, I'm so brand new, but more and more, especially since I get to do these sessions with experts, I'm like, relatively new. I'm starting to know some things despite myself, right? But it's so impressive when I hang out with folks like yourselves with decades of experience. We're getting some love for you, Toddy, in the chat. Batwan, hi Batwan. I'm glad you're here. Says your blog posts are inspiring.
Yeah, thanks, Batwan.
Yeah, that's amazing. Those of you who are watching, please do say hello. Tell us where you're tuning in from. They're both in Seattle. I'm in Austin, Texas. And also, I'm interested to hear like what folks in the chat, like what your experience with signing images. Are you signing images right now? If so, what technology are you using? Is there another question you'd like to know from chat?
Yeah, so we're interested to understand, okay, what eventually they're looking when, for example, they sign images. So are they interested in like signing with, let's say, traditional certificates or some new ways to do signing? I personally, I use a lot like PGP and like SSH keys for signing, like personal stuff on GitHub. Is that something folks are looking at? And in general, any questions around, okay, not only container security, but software supply chain security?
Yeah. If you ask that up top, we can get to it later in the episode too, as we're figuring everything out on the board. But I kind of like this angle of ending, like starting the show with the future of the project before we've really talked about the project. But it is really interesting to hear where people are at right now, so we can meet them there. And what were you going to say, Milind?
Oh yeah, so also about like where all in the supply chain or CI/CD stages they are verifying images, like at import time, pre-build, post-build signing, pre-deployment. Yeah, software supply chain is a fascinating topic, and like you can start with few controls, and you can incrementally enhance kind of the security posture of your CI/CD systems.
That's exciting and fascinating. Kormaju's here. Kormaju's a regular. Thank you so much for coming, friend. Good to see you. I'm going to start moseying on behind the light board here. I'm going to drop some links into chat so we have them if we need them for later. And I want to dig in a little bit about becoming a maintainer. You're both maintainers. I know. Well, I guess maybe what does it mean to be a maintainer? And then like when you become one, is that like a voting system? I know like everything's really democratically done in these cloud native open source spaces. So tell me what it takes. Is it a popularity contest? Okay.
I'll let Toddy take the lead here. I think he has more experience as a maintainer.
Well, I became kind of pretty recently maintainer.
Like with different projects.
More fresh memories of how do you become a maintainer. Yeah. The way I kind of got into Notary Project was I actually have a colleague that was working on the Notary Project before me. We were kind of talking internally in the company about it, what we want to do there. I was kind of brainstorming with him a lot. And he said, okay, why don't you kind of just come and start looking at and eventually helping with the development of that. So the first step, of course, as every open source project, is really start contributing, attending community meetings, replying to issues, helping with what you can, and that's where kind of it started. Of course, after that we have a voting system, and we are improving
voting system
all the time. So we would like to be a little bit more diligent on that work. But at the end of the day, so you have other maintainers that are already maintainers on the project. They can vote you in, and then you become a maintainer. The way that we kind of are looking to improve that is really based on contributions, right? So because when you have people that are constantly engaged with the project, so as you said, democratically, that's better those people to make the decisions. So as I mentioned, so we constantly communicate with Milind, with other folks on AWS side. We have folks from other companies participating, and we're trying to grow this community. So we are welcoming anybody who is interested to participate. So it's not super heavy process, and you don't need to you don't need to commit code. If we are looking for contributors who can actually help us with various things like ideas about processes, documentation, helping with architecture and specifications, so all these things.
I have a question.
Yeah.
Is it possible to be a maintainer without contributing code? You can be a contributor without contributing code.
So far, I don't think we have anybody. Actually, I think it is. So, Milind, I think it is possible to be a.
Yeah, I think that like on like strict terms, like for example, we have the specifications repo and we have implementations, and you can absolutely, like as a product manager, be a maintainer of some of the non-code repositories and be involved in the other projects as well. I think there are paths there. You don't have to strictly contribute. Like people may have a lot of experience around like good customer experiences or security background, and may want to provide that without getting into the implementation aspect of it.
That makes a lot of sense.
So I think from my side as a maintainer, I've been involved with the project for longer, probably around 2.5 years. Maintainer may be around a year and a half. And I think what was fascinating in this experience was just collaborating with people from other organizations and people across the globe with different viewpoints, people from different backgrounds. So for me, taking part in the community meetings, consensus building, I think is one of the most challenging aspects. And that exercises a lot of skills. It's fun. I mean, things can get kind of heated up in discussions, but everybody is passionate about their viewpoints and they want to kind of create a best user experience. So for me, that's the fun parts, and then kind of the technical aspects of getting to work with other people who have like really deep technical knowledge and being able to learn about things.
Yeah, that's awesome. I want to say hi to a lot of friends are here. We have Evan Shuli's here. Hello. So glad you made it, friend. And so Spindle, pew pew pew. And Nick Srinatha, hello, welcome. And then Nick the first one. How are you? So great to see you. And then we got this question first. I thought this might come up. I didn't expect it to come up before we talked about literally anything.
Yeah, I think we can talk about it at like a high level, and we can dig into later.
Okay, perfect.
So
So let's repeat the question. How similar is this project to SigStore is the question. All right, take it away, Milind.
So SigStore is more appropriate for open source projects, for open source projects that are developed and distributed. There are use cases around enterprise signing, and you may have certain security, internal requirements, compliance requirements, and that's where Notary is more appropriate. And we'll get into some of the features and differentiation later. But at a high level, that is kind of what I would say.
So, and maybe to answer the question, so they both do image signing and image verifying.
Yeah.
And so SigStore might be better for an open source project when Notary is better for something maybe enterprise or more compliance heavy.
Yeah, and there are workflows where you would use both of them for different.
Oh, I love that.
Yeah.
Cool.
Yeah, the way we kind of on the Notary Project side approach it. So when you think about SigStore, like SigStore wants to secure the open source software, like everything that's GitHub. So SigStore has very good integration, let's say, with OpenID Connect, like GitHub. I can go and sign my GitHub. So that's very, very good experience. The way we approach it with Notary Project is really enterprises. They most of the time develop software inside, and they already have signing infrastructure that is established there. So they have like X509 keys that they are using, and they like to actually have a smoother transition to more modern signing technologies than like using the legacy signing technologies that they used internally. So we wanted the Notary Project to give them a way to really easily transition to
that
this.
Makes a lot of sense. Like SigStore's claim to fame is that you don't need to manage your signing keys anymore. Instead, you could use their public ledger Recore to verify the images, which is cool. But a lot of legacies, you're saying, already have really good systems in place for managing their keys. So like that doesn't feel like an advantage if you already have a good system going for that. Yeah. But we're getting way ahead of ourselves. So let's put a lid on that and talk about what the world was like before Notary existed. Like what caused it to need to get made.
Yeah, I can speak about that. So first, maybe clarifying a little bit of the terminology. So Notary Project is the overall project that has several tools and specifications targeting like not only signing container images, but our overall goal is to go to supporting the whole supply chain for software, not only container images. So Notary Project has a specification, which right now includes the specification for signing, and it specifies portable signatures that we can use.
Before you tell me what Notary is, I want to know I want to know the problem it's solving. So I do want to capture, I think, everything you just said. But just take Notary out of your head right now and paint a picture of the world where Notary didn't exist.
I can talk about that.
Yep.
So I think the core problem is consuming trusted artifacts, and then we'll get into trust and what that means. So Notary allows you to consume trusted software artifacts. And
so before Notary, was there not a way for artifacts to be deemed like trusted? Like, was it possible you thought you were going to use a MongoDB container image and instead you're installing like some sort of Bitcoin
Yes,
miner on your computer?
Notary Project is actually, this is our reboot. This is a second iteration of these
Uh-huh.
specifications. And the previous version of implementation was based on a different set of specifications. And it did not have great adoption due to primarily two reasons. One is images are portable artifacts. You have them
Uh-huh.
hosted in public registries, so like portability. This is one of the things we'll talk about. Uh,
Okay.
Moving images from registry to registry and moving signatures along with them. And the
Mm-hmm.
second is around usability. Um, the previous specification was based on Trusted Update Framework, also called TUF, and that primarily does software updates. It's a framework for secure software updates. Works great for where you're the centralized publisher and you're, say, publishing browser updates or system software updates. But container workload deployments are different than that. So, for example, with container workload deployments, you want different versions to be supported. You want support for rolling back, uh, things like that. So there were
Mm-hmm.
usability challenges, and even though Notary, the first version, which was just called Notary tooling, was supported by a few registry operators, it didn't get much adoption. So we spoke more to customers and users and figured out why usability has been a problem. And like we started from scratch around, we want to build with integrity and authenticity, and we'll talk a little bit about that, what it means to
Mm-hmm.
consume tamper-proof images. It hasn't been modified. That is integrity.
Mm-hmm.
Authenticity. It is from the person that claims that uh, that they created the image. And we built on these basic concepts. We put in some extensibility features, like Toddy said. Uh, Enterprises have their existing infrastructure to integrate and integrations with third-party key management tools. So we added those features. So at a high level, it is integrity, authenticity, that is your security aspect, and bunch of extensibility features.
So before Notary Project, it was people had a hard time being sure where their container images were coming from or that they haven't been tampered with. That's correct?
Yes, there were few toolings, but they had adoption challenges as well, and
Okay.
Notary tooling being one of them. And we kind of
Okay.
started from scratch uh, and came up with this new set of specifications called Notary Project specifications, and the tooling is called notation.
Okay. So with early signing tooling, there were adoption problems. So now I'd like to talk about what Notary is. And so do we want to do two definitions? One for like Notary, the related, I'd associate Notary period just with image signing and verifying. Yeah. Do we want to do two definitions? One for Notary Project, one for Notary image signing?
Well, let me take a stab of that. So first,
okay.
I don't think we should associate container image signing with Notary, because there are multiple tools right now that can do that. As Milind mentioned, Notary was kind of the first tool that did this. So it started in 2016, 2017. And it got some traction up until like 2019, but adoption stalled due to all the issues that Milind mentioned. Now, when we talk about container image signing, so you can use cosign for container image signing. This is actually part of the SIG right? You can also use notation for image signing. And the goal for Notary Project is we would like to have a specification that it specifies what the signature is and how the signature is created for the container image. But different tools can implement that specification. And
so the specification that defines what exactly?
how the signature is created.
Cool.
And as Milind mentioned, so notation is another tool under Notary Project that implements this specification. So we have a library that you can use if, for example, you want to integrate the signing and the verification into other tools, like, for example, Kyverno is using our libraries to do that. Registry is another tool which is using this, and we can talk about that later on. And Notary Project is kind of the encompassing project for the specification, the notation tool, and we still keep the kind of the Notary, which is a client and server implementation under this project, because there are still some customers that are using it. And Notary is most famously actually known as Docker Content Trust. So that was the most adopted implementation that you have seen of Notary.
So is the Notary client server an implementation still of the specification?
No, Notary client server is not. So Notary client server actually complies with the update framework that Milind mentioned. And that's where we kind of hit the problems with the usability and the adoption, especially when you, for example, need to copy image from one registry to another. That's why we kind of did the reset, and we said, okay, now we would like to create a specification which will enable portability between registries. So if I sign something, let's say in my GitHub container registry, you can copy my container image with my signatures and verify it in your own private registry.
Cool. Are there any more notable sub-projects of the Notary Project that you want me to capture here?
Not right now, but we're looking to kind of extend that to the future. So they are like under the specifications, in addition to the signature specification, we also have specification how you do the signing and verification workflow, but we just call them the specification part. We have part also specifying how you can extend the notation CLI with plugins, but everything is kind of under the specifications part.
Yeah, at a high level, this captures it well, Whitney. I think for the purposes of this talk, the Notary Project, which is the set of specifications, and notation, which is an implementation, is what we'll majorly be talking about. So those two terminologies are, you clarified that.
Excellent.
And there's a question in the chat from Kumar Raju. What is TUF in Notary Project? So TUF is what the legacy Notary tooling implemented. It's called the update framework, and it's for secure software updates.
I will probably be capturing that later when it becomes part of the story.
Yeah, I think the updated specifications do not use TUF. That is the legacy tooling implemented TUF, and Notary Project updated specifications and notation do not use TUF.
Okay, excellent. That's I think a problem that a lot of projects have is when they used to do things one way and then they change to something new, to like lose that association with what you used to do. I see that happen often. Yeah. All right. So this is the part that I like to control and get on the board at the beginning. And now I want y'all to be in control in terms of what you want to teach to help us get a fuller understanding of Notary Project.
Sure. I think we can start with just basics of what does it mean to trust an artifact, and images
I like it.
Type of artifact.
I have a question. Is this for OCI artifacts across the board?
Yes. So we'll talk, and I don't know how familiar are the listeners, or do you have any questions about OCIs, but we can talk about OCI.
Uh-huh.
Right now, we do use OCI layout and OCI registries to sign container images with Notary Project signatures using the Notation tool. But we are also looking to sign in the future arbitrary blobs that do not actually use OCI. This is kind
Okay.
of in discussions right now that we have in the community, how we can do that in the future, what we can do in order to make the tooling more extensible and sign not only like OCI artifacts, but other types of like simple files, for example.
Cool. Yeah.
If you think from let's say workflow point of view, when you actually think about container secure supply chain or software supply chain in general, like when you create a piece of software, you create a, let's say, executable or the container image as part of your build, but you also generate right now additional artifacts. So based on the executive order from the president, you may need to generate a SBOM, right? This SBOM doesn't need to be stored in OCI registry. It may be stored as attestation, but for example, we have software that we distribute not through OCI registries. You go and download them from certain other repository. So you may want to actually sign this SBOM or this piece of software with Notary Project signature and allow whoever downloads it to verify that the signature is valid and nobody tampered or replaced the binary or the SBOM.
That's great. It's almost, you can almost think of it as like an actual real life notary that stamps, like puts the emboss symbol on a piece of paper. It's not just for government forms. You can notarize anything.
Yeah, exactly.
Yeah. All right. So what does it mean to trust an artifact?
So I'll start with like top level basics of integrity and authenticity, and then we'll talk about a bit about supply chain security and attestations. So integrity is just that something hasn't been tampered. So if you have something being transported or stored anywhere and that it got tampered, so something having integrity check means that you have assurance that it has not been tampered. And authenticity is the other property, which is it is from a trusted source, or it is from the party that claims to have produced it.
Okay.
And you would specify who you trust. You have a determination of who you trust, and when you get an artifact, you can determine that this artifact did really come from that party.
Okay.
All right. Yeah. So and then
that answers that question, right? That's a great.
This is like a basic, like what does it mean to trust? And we'll talk about like in container image context, why this is important. So generally you have, and we'll talk about portability a few times. Container images are open specification based format, and it can move across registries. Typically, you have base images sourced from public registries, and you build upon them and create your own images. You also have applications which are composed of multiple images. You have your application image and you have sidecars being deployed. So in all of these cases, and so you have workflows where you import images, you build on them, store it in internal registries, and deploy to your environments. And you cannot rely on just like what was the source of this image, like this particular URL where it was downloaded from. You can these images from anywhere. So source does not imply trust. You need something else like signatures, which
Mm-hmm.
which you can use to determine trust independent of where you got the image from. That's what signatures allows you to do.
And think about that, like you're downloading images from public sources, and very often, for example, those sources may be compromised. Right?
Uh-huh.
And even if this public source gets compromised, if you have, for example, signature on the container image, you can still kind of trust that it is published by the publisher that claims to actually publish it there. Unless, of course, so we have cases where the signing keys get compromised, right? So there is no bulletproof security. But the trust now is not put in the public kind of repository or registry. It is put
Mm-hmm.
more on the do you trust the publisher?
So basically, without relying on any other factors, or even if those other factors get compromised, you can be sure that the artifact you finally got did come
Uh-huh.
from a particular part, irrespective of, say, the registry got compromised or the
Ah.
code got compromised, or even in your internal systems, you may have broad access to your registries. Developers may have access to your internal registries, and you can still have policies so that, like insider attack and those kind of threat vectors, you can address all of them by just relying on signatures.
Uh, so I'm going to repeat this back to you. So we talked about like artifacts are everywhere. There's like base images, there's like app images, many of them that are built on those base images. There's third-party dependency applications that you're bringing in, supporting ones that have images. There's like SBOM artifacts being built. So what's helping the signatures are ensuring that the artifacts are not compromised, even if the sources do get compromised.
Yeah. So
Is that a good summary?
those two properties of integrity and authenticity. And we'll touch upon a bit like how this is evolving. Like many in the audience would be uh, aware of code signing, basic code signing, because you install applications on, say, Windows or Mac, they would be signed. Um, like how that is getting extended. So those are for applications, but for software development, we have a whole process by which you uh, develop and validate and deploy software. And generally, this is called software supply chain. And why software supply chain security is getting more important is your base of trust is broader than what it used to be before. Before, you used to just rely on, say, a set of compilers and base frameworks and develop your applications mostly in-house, write your party code on it. Now, a lot of your application is just comprised of open source dependencies. So you have this dependency on open source components, which can be hosted on GitHub and other sources. You also have more complex CI/CD systems, which allow you to like have agility, etc. And the security of these systems, like your build system can get compromised, your import system could get compromised, and there have been actual impacting attacks along these lines. So software supply chain security is securing all of these systems, processes, and being able to ensure that it's not just the end artifact that you're deploying that is secure, that all of the systems and upstream dependencies are secure as well.
The artifact goes through a lot, from the time it comes from the source to the time it's deployed in production or whatever.
Yeah.
It seems to go through a lot of different places and changes and all over the place. So this is a way to ensure the whole time that it's not getting compromised.
Yeah. And then we'll
Cool.
touch upon attestations quickly, which is,
Before you do, I think I'd like to write a definition of software supply chain because it seems like it's going to come up a
sure.
lot. What do you think about that?
So that would be the code, systems, processes, all of the things that touch your software development uh,
That's
process
it.
or software development activities that leads to deploying software or creating software. Like, I think the most basic definition is that it's super broad. Anything that is involved in your software development process.
I like that.
We very often actually associate this to the supply chain for other things, like for example, food. You have like the farmer who actually has cows. You get the milk. The milk gets delivered to like a company that creates cheese. So they create the cheese, then the cheese goes to the store. You buy the cheese from the store, and you're a consumer. So that's kind of the supply chain, like typical supply chain. Now, from the software, you have similar thing. Like, let's say, very actually, I don't think there is any company right now that produces all the software they need, right? So you take piece of software, whether from external vendor, take, for example, NVIDIA, right? So you take NVIDIA base image from NVIDIA, then you add your machine learning model because AI is very popular right now. Then you deploy this machine learning model to your cloud service. So those are the steps that you go. Or you take piece of software from open source, add it to your base image that you took from Docker Hub. You actually add some additional software or piece of code that is your application. You deploy it again. You have different sources and different steps that you go through in the supply chain for software. And as Milind said, in every actually step, you need to verify, am I taking something that I trust? Do I trust the piece of software that I'm acquiring from other source? And after I build something, then I sign it, so the next step can verify that I am the one who built it. That's where you have the signatures actually helping, because you ensure for the next step in the software supply chain that what is produced in the previous step is something that you still trust.
Yeah. I think tying back to the analogy that Toddy gave, like in the cheese production supply chain, the compromise would be like contamination, right? Or having some input which doesn't meet the quality standards, things like that.
Kormashu has a question. How to trust the source artifacts that came from maintainers and the publisher before the software, the application's created?
So I think this is where some of the like newer technologies like Sixtor, if they're open source, and if you have like vendor software uh, notation, a Notary Project uh, would be apt there around. So maintainers and publishers would also sign these artifacts, and as a consumer, you would have to kind of know what is the certificate or what is the identity that they are trusting with. So I think the default stance, and we'll get into this, the default stance you should have is you start with I don't trust anybody. And then you define who are the third party vendors or open source projects that you trust. And you figure out what are their signing identities, and then you set up policies which say I accept software from which are signed by these. So signing is again the technology that allows you to do this, and there are different ways, tooling mechanisms in which can be implemented. But it's kind of the same thing repeated over. When you take third party or open source artifacts, ideally if they are signed, you are able to verify them and be assured of them at your import time, and then you build your own thing on top of it. You sign it, you distribute it to your consumers, which may be just internal to your organization. And before deployment, you can again check the signatures that they are authentic before you run them on workloads.
And also signatures are happening every step of the way.
Yeah,
But
actually, the important thing to understand here is uh, like like don't trust anything based on like where it came from, even if it came from a particular GitHub repository or a public registry or any location. Those
uh-huh.
locations can get compromised. A GitHub project can get compromised through maintainer compromise, access compromise, etc. So you have
Mm-hmm.
to rely on these mechanisms like code signing to independently verify, and you have to define who you trust. Some of it is may seem cumbersome, but like this is how the security works. There's no easy way to say I just want to consume software and they should all be trusted. You have to define who you trust.
Just like with your friend group.
Yes. So I was gonna say that, like, it's like in the past we were like, look, I'm a friendly person. I'll trust everybody, and I approach every person like with I give them the benefit of the doubt and say, okay, he's a trustable person until
Yeah.
they do something that actually you gives you a reason not to trust them, right?
Uh-huh.
And we had this approach with the software in the past. So, for example, I go and download everything from Docker Hub, and I trust everything because, well, Docker Hub is the registry. However, what we learned is that not everything that is published to Docker Hub is trustable, right? So on a daily basis, you get like malicious container image published, typo squatting, dependency confusion, so all these kind of jargons in the security space that we name each attack. So the way that actually we are switching this now is you can think of, as Milind said, so don't trust anyone means before you actually prove that this person or this piece of software is trustable, doesn't matter if you took it from the same vendor that you've been using for the last 20 years, you need to verify that the software is still trustable before you actually put your stamp of approval to trust it.
Yeah.
We'll talk about what in code signing, what it means to establish trust. How do you specify who do I trust?
Excellent. Quickly to Koramaju's question, you said, how do you trust artifacts that come from the publisher? And Milind, you very correctly said Sigstore is a good way for that. The reason Sigstore is good for that is because instead of it uses PKI a little bit, but really you throw away your public key, and instead of verifying it with keys, it's verified because it uses a public ledger. So you can verify that the image is correct by checking the time signature with the ledger. So it just has a transparent and public and tamper-proof way to verify that doesn't work as well for internal images or like every step of the software supply chain, which is where the notation is a better choice.
Well, even in that situation, you can have exploits, right? So take, for example, like I use Sigstore to sign things, right? The way that actually Sigstore adds the thing to the ledger or the entry to the ledger is like they verify that my GitHub username signed that thing. And that goes to the ledger, but what if, for example, my GitHub account is compromised?
Yeah.
How can you verify that one? Because everybody who compromises my GitHub account can go and sign with my GitHub username, and that ends up in the ledger, right?
Yeah.
So that's why you need to verify each individual like artifact, not blanket trust into my GitHub account, because I may be compromised, I maybe actually become a malicious person and add some malicious piece in my code, and this happened many times over the years.
Yeah, and we'll talk about a little bit of this around like this gets into revocation. How do you invalidate trust in response to like these security events like losing access to your credentials, etc. And we'll talk about how notation supports that versus like how it is more difficult to do with Sigstore for example. And like there may be cases for even open source projects which want this control to be able to say, I signed something, but if I have a compromise, I want to indicate to all my consumers in a very easy way that trust has been revoked. And you can use notation there. Like we'll talk about the differences and like, yeah.
Cool. What do you want to do next?
I think we can dive into, I think we talked about a bunch of kind of context setting. I think the last piece would be attestations, because this jargon will come up, and I think the next thing after that we'll jump into all the Notary Project stuff.
All right.
So attestations is, I think a simple way to think of it is richer signatures. Previously, signatures just used to mean somebody has signed off. Typically, before you publish software, somebody would sign it, and that vaguely means this is good to consume. And in modern, like in modern world with supply security chain attacks, etc., what is good to consume is more difficult to define. You need more metadata than somebody just saying this is good to consume. So that's
Okay.
where other things like vulnerability scan reports and software bill of materials, SBOM, those kind of artifacts, or build provenance, those are additional metadata, rich metadata that allow you can capture those, you can store those. For example, with the log4j or log4shell vulnerability, right? If you are consuming packages which had a log4j dependency, having the SBOM along with the signature, which says this software uses log4j version X, there are ways in which you can consume this raw SBOM data and in your tracking system. There are open source projects for that as well. And when you want to react to a vulnerability, log4j version X is vulnerable, you can go to your systems and say, find me all the things that depend on log4j. Find me all the environments where these were deployed. And that's where the richer metadata helps. So attestations are like signed statements, and those statements can be SBOM, vulnerability reports, and other rich and structured information about the software artifact.
Just to add to that, so Whitney, think of it like when I produce a piece of software, right? As we mentioned, we create these additional either statements or metadata or both, and you capture the current state of how you created this piece of software. One of the things that we need to think of is like things change over time. For example, today I create a piece of software and I scan it and has no vulnerabilities. So I create a vulnerability report, attach it to my container image. I sign both, and I ensure that nobody can actually go and modify the vulnerability report or the image to say there are no vulnerabilities. But tomorrow there is a vulnerability discovered, right?
Yeah.
And I need to update this information, so I can go and scan it again. I can generate a new vulnerability report and sign it again and say, okay, this is the latest vulnerability report. You can ignore previous ones and not pay any attention, because the previous one may say there are no vulnerabilities. The new one says actually there are a bunch of vulnerabilities in your piece of software. So those are attestations. And one of the things that we need to think of is that those attestations need to be dynamically updated. It's not only the state when you created the software, but take, for example, I created a software, publish it to Docker Hub, created SBOM, created vulnerability report, everything looks great. Then I take this piece of software from Docker Hub, import it into my registry together with all the attestations. I run my own vulnerability scan, and my vulnerability scan says something else. I can update those attestations and say, no, I don't trust what is published on Docker Hub. I trust my own scanner, and this is the information that actually I want you to consider down the pipeline when you use this image. And Notary Project, when you sign those things, right, I can actually internally in my enterprise, I can sign it with my own signature, and I don't need anybody in my, for example, enterprise to trust the signature of the external vendor, because then you expand the surface for attack. So if everybody trusts everybody, everybody can be very easily lied to, right?
Yeah.
Right? While internally, so I am more willing to trust, let's say, my enterprise key than the Toddy's GitHub, for example, name, right?
So is it correct to say attestations are signed statements that can be dynamically updated?
They can be
appended.
I don't know whether updated, because once you sign the statement, you cannot update it. But you can add a new statement that invalidates previous statements. So
okay.
I think there's some attestations. So for example, CV scan is a point in time. So you may generate a new scan regularly, and that is an example of something that can be updated. And SBOM is static information. Provenance around how it was built is static information. So I think the important part is these are rich metadata, structured metadata, and they need to be signed as well, because they need to be signed similar to the image, because you need to trust that information as well.
I like actually what you're writing. So the right word is they can be appended with new information when it is discovered.
Yeah.
Okay. I like that. Can be appended. With new info when it is discovered. And then attestation, rich metadata.
Yeah. Even when you think, for example, build provenance, right? At certain point of time, I may trust this build that actually was just about. But 2 weeks after that, I may discover that my build infrastructure was compromised, and I may want to add attestation to say, don't trust this image because it was built during a time that the build system was compromised.
Okay. I'm going to write CVE because that is easier. I'm newer to tech, and when I got here, I was like, there's so many acronyms. I'm never going to use acronyms. So and then sometimes it's just, so FSCVE, which stands for Common Vulnerabilities and Exposures, FSCVE is found. Cool. I have a good sense of attestations, I think. If those of you who are watching, do you feel good about it? Any questions? Excellent. How are we on board space versus how much you want to cover?
Yeah, I think it's good. We'll see. I think we did a lot of context building. I think we'll jump into notation stuff, Notary Project specification now, and I think it is good.
Okay. What's next?
I think we'll talk about signing and verification to start with, and then we can get into some of the extensibility features for integrators. So let's start with signing an image.
Cool. Tell me about signing an image.
So what we do here is we sign the hash of the image. Registries are content addressable stores, which means everything in a registry is referenced by hashes. hash of the content. So you don't really have to sign, like download the whole image and sign it. We just sign the hash. And we'll talk about what exactly it means to sign it. So you generally have like a asymmetric key pair, a public key and a private key. You sign with the private key, and then you distribute the public key for anybody that wants to verify it. So you sign the hash with the private key.
PKI. Is that private key infrastructure or public key
So there's
infrastructure?
public key infrastructure. I think for simplicity's sake, we'll just say sign the hash with the private key.
Okay. That's a whole big can of worms, you know?
Yeah, PKI is like the broad CA certificate authority infrastructure processes, etc. A bunch of it goes into setting up a CA. So with the private key, and you would just say verify with the public key, and then we'll talk about like that. That is the simplest way to start.
Excellent.
All right, and then in practice, how this works is we have certificates which are signed public keys, because when you so for example, I'm distributing software. Say I generated a public key private key pair, and I want everybody in the world to verify software that I'm distributing. I would provide them my public key, but I could just publish the public key, distribute it in any way, and that can be intercepted, modified, tampered as well. So how does somebody trust my public key? How did this, like, this public key does really belong to me? And that is where certificates come in, and CAs, which are certificate authorities, come in. So the certificate is a signed public key. Somebody else is signing the public key, and this somebody else is a central authority which is broadly trusted. So, for example, in an enterprise, you may have a trusted route through which, like through a trust chain, all of the certificates chain to a single root certificate. Or you have public CAs, which when you go to a public CA, they'll actually check that you are a legal entity, a person, or an organization. They'll verify your identity, and only then they will give you a certificate. So now, when I want to distribute my public key, I distribute my certificate. And the consumer of the certificate has to check two things: that my certificate was signed by a third party that they trust.
What was the first? What was that?
So
So we're
basically,
verifying the
you
public
verify
key.
that the
Two
public
things.
key is trusted.
Two things. What was verify that the public key is the
And
source of the
then
public
you are
keys?
able to verify the signature. Again, like we're getting into the verification workflow here, but at a high level, this is just like why certificates exist, so that you can
Okay.
you can prove your identity to somebody else
Okay.
in a easy way.
So really, a certificate assigns public key. It's used to distribute the public key and verify the public key.
Yeah, the distribution there is like decouple the different mechanisms to distribute it, but it's really how do you authenticate an identity? How do you trust an identity? So somebody,
yeah, I think like we talk about integrity and authenticity, right? Here is where we go to the authenticity part. So you want to know that the public key really belongs to Milind when you actually want to get a software from Milind. And the public key being signed by, let's say, the certificate authority means that the certificate authority verified, let's say, the company information for Milind or his driving license and so on. So it gives you some assurance that this is really Milind and not somebody who tries to represent themselves as Milind.
Yeah, I think the easy way would be in that analogy, say, Whitney, you are the certificate authority.
Okay, I
I
like
would
that.
come to you and I would tell you, sign my public key because I want to distribute my certificate. And you would
Okay.
say, prove your identity in some particular ways. Of course, you know me, but like I would give you my driver's license or other things, and this is who I am. Then you sign it with your private key, and then the world knows you. You have built trust. So,
The way
so
I've heard it, actually, with you bringing up driver's license, is like
yeah,
the driver's license company, like the issuer, is the certificate authority.
right.
If
Like,
you want to get a driver's license, you have to prove other ways
yes,
that prove your identity, and then they give you a driver's license that
yes.
you can show to people.
So
And
when
that's
so in that example, when I go to Toddy and say, "Here's my certificate," Toddy would check two things. Toddy would check, is this certificate signed by somebody that I trust? He already trusts you. So that you are the root trust you. And then he would check, a signed artifact came in. Can I verify this with my public key, which was inside the certificate?
So let me play a little bit with words here and say notary. But when I say notary, I mean the real notary, like real life notary.
Okay, yes.
When you go
Who
to
stamps to a boss's paper.
Yeah.
Yes.
They have a stamp and they check your driving license or your ID and they say, yeah, Milind actually is this one. I will put my stamp, my notary stamp, and I'm registered with the state officially. So I have some kind of level of assurance that if I look at the document that the notary stamped, right, and it says that Milind is the one that actually created this document, I can trust it more than if Milind gives me a piece of paper that he just signed.
It just says, I am Milind. Here you go.
Yeah. Here you go.
So that was a bit about like roots, CAs, roots, and public key, private key. In terms of like getting back to the signing workflow, we are signing a hash with a certificate. And what we do there is we have a plugin framework that allows you to integrate with different providers.
Okay. I'm writing this on the board and I'm following. Yeah. But like I want to be clear about what we're talking about. Are we talking about generally signing an image, or are we talking about Notary's version of signing an image?
Both are similar, actually. Like generally signing an image means you go through this flow, and this is what Notary does. What the Notary Project specifications defines is what is the signature format. We'll talk about JWS and COSI being the actual signature formats and how to verify it. So the specification gives you the exact details of how to do it. This is the general concept.
Okay.
And the specifications also allows any other tooling to implement notary compliant, to generate notary compliant signatures or to verify notary signatures as well. And we have libraries in Golang, but there's also specifications that allow you to implement it yourself.
All right. So what would you like me to write about Notary in relation to signing an image?
So in Notary Project, it's basically we have a specification which tells you how to generate a signature.
Okay.
So there are two aspects, like what is the signature format, generally called as a signature envelope, and the process of generating the signature. That is what the specification provides.
I think there is one more piece, which is like, what is the level of security that actually we accept, which is whether that's actually certain encryption standard. So we limit the encryption standards that we support to more secure encryption standards. So, for example, you cannot go and sign with, I believe, MD5 or something that actually is not easily hackable.
So I think Milind said two more things about the specification specifically. So there's an encryption standard, and what are
the crypto standard, the signature envelope, which is the format. You can just say that is the format of the signature.
The signature
envelope.
And I'm going to write format.
Yeah.
Signature format, and then what's the was there a third thing?
And then the how to create the signature we already talked about. You take the hash and you can add that. That would be how to generate a signature. Like you have all of these things in the specification. And again, we are talking about like more abstract things here. We'll talk about what does notation tooling actually do when you sign an image. And what it actually does is you say notation sign, here's an image reference, and the image reference can be a tag based or a hash based, digest based. Notary will get the image descriptor from the registry, it will sign it, and then it pushes that signature to the registry. So you have the images stored alongside your image, images, the signature stored alongside the image. So when you verify, it's right there for you to download and verify it.
And this is where kind of your initial question about OCI comes, because right, we use the kind of the OCI APIs that the registries expose to go and, for example, find the signature based on the reference to the image that we receive as part of the request to sign or verify.
So does this simply capture what you just said? Notary signatures are stored alongside artifacts and can be used for verification.
Yeah.
Cool.
And this gets into like when you move images from registry to registry, you can move the signatures as well. You don't have, you can implement flows where you don't have reliance on any external endpoints. You can just only have a dependency on your registry.
So therefore, signed artifacts can move between registries.
Yes.
We have a question. Let's see. Cormaggio, you're the best. Notary Project made this sign an image automatically. I'm not like sign with the hash and verify PKI. I'm not sure I understand the question.
Yeah, I would like some clarity as well. Currently, I think if I understand the question, it doesn't sign it automatically. There's tooling. So you typically use tooling like Docker CLI to interact with images. You would use the notation CLI to sign and verify images. You typically would like script it along with your existing build and Docker pull for deployments as a post step for build and as a pre-step for deployment. So before you deploy, you would call notation verify this image. So these are additional steps that you would add to your existing workflows.
Cool. All right, what's next?
Toddy, unless there's anything we want to add on the signing part, we can get into verification and we can talk about plugins in the extensibility part.
I think we can talk a little bit about the signing formats and the envelopes and what are the benefits actually of each one and where you can use it. That's one thing that and I can actually start. So as Milind mentioned, we have two signing formats. One is JWS, which is Java Web Signatures, very similar to Java Web Tokens that are used for authentication.
JSON Web Signatures.
Yes. Sorry. Thank you for correcting me. The other one is the COSI format, which is actually a binary format. It's not JSON or text-based as JWS. And the reason that actually we added those two type of formats is, first, everybody knows JWS or JWT. So current implementations, they, for example, people are familiar with Java JSON Web Tokens. They know how actually to create such type of signatures. It's very easy migration. If, let's say, I want to sign stuff, this is already used in the authentication flows, and I can use the same signatures for signing content. Go ahead.
Will you repeat the first one? This is all brand new to me. So JWS was the first one?
Yeah, JWS stands for JSON Web Token, Web Signatures.
Web Signatures.
Okay. And you said, and so this is pretty ubiquitous, like it's a common.
Yes. It's very common, yeah. It is JSON actually file or JSON.
Yeah, it is JSON format, and it can be used to sign JSON or binary content. I think at a high level, this is an existing and widely used signature format, and that is one of the formats that we support. And then we added support for COSI. Toddy, if you want to talk about COSI too.
Is COSI COZY?
COSE. That stands for CBOR Object Signature and Encryption.
Well, like cyborg,
it's
like no.
CBOR Object.
Hold on.
It was cyborg, yes.
That
no,
CBOR?
CB like Bob.
Okay.
And I can post.
Not unlike cyborg. I like cyborg better. CBOR, okay.
Object Signature and Encryption. And
signing and encryption.
Signing and encryption, yeah.
Okay.
And this is actually a more recent format that is binary. One of the actually benefits of this format is it's very widely used in applications like Internet of Things, where you have a low-powered device that, for example, if you need to go and parse text formats like JWS, you will lose more power, and you require more CPU capacity to do that. And the COSI format is, once again, provides better performance and also gives you the ability to sign even things that you can deploy on, let's say, controllers or sensors that are low-power device, and still ensure that there is integrity and authenticity of the software that gets deployed on these devices.
Interesting. And is this, you said it's stored alongside, is it stored like in the metadata? It moves with the image?
No, it is stored as the so-called OCI artifact. So if you think about the container image is right now a OCI artifact or OCI image. So the way that image is represented in the registry, you have a manifest, and this manifest points to the actual blobs of the image layers.
Okay.
The signature is actually stored the same way. So you have a manifest for the signature, and the single layer that actually represents the signature, which is either the JWS file or the COSI binary, is linked from the manifest. And the signature manifest has a special field that says this signature actually refers to this particular image. And as Milind said, everything is content addressable, which means everything is referred by the hash. If I change anything in the image, in the signature, in the manifests,
Mm-hmm.
those links, they will
The
be
signatures
broken
going
and you cannot validate it.
Cool. Excellent. What's next?
We'll talk about verification next. And I think the way to start about verification will tie back to the default stance that you have there. So the Notary Project tooling, that is notation, does not trust anything by default. And you have to configure it, and we'll talk about how you configure it.
Oh, okay. So by default, what trusts nothing? The notary verification. What
Sure. So
exactly is it being
if you
trusting?
just install notation and say
Mm-hmm.
verify this image, it wouldn't be. It would say it doesn't trust because you haven't defined what you trust or which parties you trust.
Mm-hmm. So by default, notation trusts nothing.
And this is what we wrote in the specification also. So by default, doesn't matter that you have a Notary Project signature on your image. You still need to do additional verification and say, do I trust the person or the enterprise that created that signature? So it's not only that I have signed it, but I need to verify that, well, I still trust whoever signed it.
Mm-hmm.
And I still trust that this signature is valid. So there are two steps. One is like who signed it, and the second thing is it still actually trustable as a signature? Because it may have expired or be compromised.
Yeah, so the two pieces that you have to specify there is, we'll call it the trust root.
And that's who made the signature?
Who issued the certificate? Like in the example that we were talking, like where I said, "Hey, Whitney, issue me a certificate," and you are an authority, like so that is the authority that issued the certificate. That is called the trust root. And the second is the identity who signed it. So that is called trusted identity.
So in the example, you, Whitney, as the notary, are the trust root, and Milind is the signing authority.
So I signed the image and I'm distributing it. So I'm telling everyone, trust this image if it is signed by me. But the question is like, who vouches for my identity? And we are saying the trust root or you, Whitney, are vouching for my identity. So two pieces of information there.
I follow that. So the identity who signed it, is that an attestation, or is that just whose public key? So this is like the CA?
Yes,
And whose
not
public
the
key?
CA,
Okay.
the actual, like the vendor or the open source project maintainer or
So the
developer who signed it.
trust root is the CA.
Trust root
Trust.
is the CA.
Okay. And then this is who the public key.
Yeah, that is just you can say that is the entity or the signing entity. Yeah. That is the person who signed the artifact.
Got it. If they sign the artifacts, then it's the private key.
With their private key, and then the certificate that they distribute contains their public key.
Got it. I feel like PKI is like complicated enough, and public and private, like those words are so similar to one another. It just makes private key.
For the end users, though, they don't really in their policies they don't specify the keys. Like they just specify certificate attribute. So they say this certificate organization was this, the name was this, etc. So they use human readable attributes, not like the public key, private key, like hexadecimal strings, etc.
Okay.
So I think the part I want to emphasize here is you define this through a trust policy. There's a document called trust policy. So
Mm-hmm.
in notation tooling, you write that policy. We have some examples there, and we have crafted that to like meet a lot of different customer scenarios, because like from kind of what I've seen, like the usability of this is important, and like flexibility around different scenarios. And so we have different verification levels that you can specify for your. So there's like a strict verification level that does all the checks. There's a permissive, there's an audit, and we'll just talk about these three. Like you can do a strict verification, you can do a permissive verification, you can do an audit verification, and like in which scenarios you do that.
Verification levels, and you said there were 3 of them.
Yeah, there's
And,
there's
and
yeah, there's three, and there's a last one which is just it'll skip the verification, and there's a scenario for that too. So there are four. We list them
Okay.
all out.
Okay.
Strict,
Strict,
permissive,
permissive,
audit,
audit, and skip,
and skip.
which is the most permissive.
Yeah,
So,
there's very specific use cases where you want to use skip. You don't want to use skip too often.
excellent.
Yeah, I think in terms of whiteboard space, I think we will I will just define what these are, and I think we want to keep some for a few other topics.
Okay.
The strict does all of the checks. So in all of these, we do check for integrity and authenticity, and there's some others like expiry and revocation check. We'll talk about revocation check a little bit towards the end. But strict is you want to do all your checks, and you don't have any restrictions on, like, if you do a revocation check, if you do network calls for those, you you are okay with doing that. Uh,
Mm-hmm.
Generally, like during your import time or build time, you can use this strict that will do all of the checks. And then the permissive doesn't do some of the time-based checks, uh,
Okay.
like revocation or expiry checks. Or revocation is something which requires an external network call, and you may
Uh-huh.
be, for example, operating in a air-gapped environment or in a network setup where you have outbound connections restricted only to specific services, and you don't want to do revocation check, or you don't want to do expiry based checks. So you can use permissive, so it still gives you the authenticity and integrity, but doesn't do some checks which balance it out with like availability and network and like
Time.
gap situations.
Mm-hmm.
Audit is just does all the checks and just logs it. So you don't,
Mm-hmm.
signature verification doesn't fail, but you
Mm-hmm.
know where what things are failing available as logs.
Mm-hmm.
And this is where it gets into like typically this is not a black and white, like I have 100% adoption or I have zero adoption of signatures, right? It is an incremental process.
Mm-hmm.
You have existing workloads, high availability critical services. You just don't want to put a strict policy and
Mm-hmm.
everything just stops. You want to
Yeah.
incrementally adopt it. So that's where like you start with audit. It will tell you which things are
Evaluate.
signed, which things are not signed. You can ramp
Uh-huh.
it up to permissive. You can ramp it up to strict based on what you want. And then the skip is really like we talked about workloads being composed of application images and sidecars, etc. Right? So there are multiple images. They may come from different sources. You may not have some images being signed. So you can use skip to say this specific image, skip it because it's not signed yet. But all the rest
Okay.
of it, you verify.
Okay. That
So,
makes a
so
lot of
these are
sense.
like kind of some controls we have built in the policy language
Mhm.
that makes it easy to incrementally adopt and like for a variety of situations.
Mhm. I see this sort of thing in policy tools to help incrementally adopt those too.
Exactly.
I like that. Mhm. Is that on the screen? Yeah.
And I think the next we'll talk about revocation a bit, and we can get into some of the extensibility features.
Okay. And what did he say was next?
Revocation.
Revocation.
Yeah, I
We
think
don't.
that would be a new topic that we'll talk about. There's a question from Kumar Raju.
Oh,
Does Notary Project make integrity and authenticity automatically? Um, like I don't understand the full context, but like generally, just because something is signed doesn't mean it should be trusted. Like this goes back to don't trust anything by default. Notary Project and notation tooling gives you a mechanism, which is you can sign images if you're distributing it, and you can verify images if you're consuming it. You need to define who you trust, and once you define who you trust, then you can get the integrity and like authenticity assurances. But at a high level, like uh, just because a signature exists doesn't mean it should be trusted.
Maybe I don't know whether he can clarify the question, but I think he may be going back to the original Notary implementation, where when you push the image actually and
Right.
it gets signed. So the way that worked in the original implementation is that there was a completely separate infrastructure that was sitting next to the registry that was managing the keys. And also when something gets pushed to the registry, this infrastructure monitors what is pushed to the registry and automatically signs it. So the new specification doesn't have such functionality specified. So the Notary Project specification for signatures and the notation tool does not do that. The reason being is we would like to use existing infrastructure for managing the keys. So we do not think that, for example, key management belongs to the registry, and OCI doesn't have any part of the specification that actually specifies key management. And there are enough key management systems that are actually very secure, much more secure than infrastructure that actually we bring together with the registry, that you can store the keys, like hardware security modules and so on. So this, as Milind said, with the new specification that we created, our goal was portability of the signatures and not to actually automate this process as part of the registry infrastructure. So that's kind of the big difference between the implementation of Notary that was based on TUF and the Docker Content Trust was using, and the new kind of specification. So with the specification now, you can use any KMS systems like AWS Signer, Azure Key Vault, anything else that you run, whether internally or externally. Like Venafi is actually working on a plugin for that, and so on. So I can use my existing key management infrastructure, and I can use notation to actually sign as part of my CI/CD pipeline or as part of my import and so on. The other thing with kind of the previous implementation in Notary was like the signature happens when you push the image. One of the things that we are also targeting in the future is I would like to sign something before I push it to the registry. And with the implementation, the TUF-based implementation of Notary, I cannot do that. The reason being is like, if I don't trust the registry that I'm pushing to, between the time that the image is pushed to the registry and I push the signature, somebody may replace actually the image, or it can be used for man-in-the-middle attack to actually give me something else to sign over the line. And that's what the new signature specification avoids as attack, because now I can also sign before I push to the registry. And I decide when I sign it and not the registry infrastructure. So think of like the registry may not be a trusted actor. Like I may want to actually push signatures to Docker Hub and I don't trust Docker Hub, or I want to push signatures to GitHub Container Registry and I don't trust the GitHub Container Registry, but I want to ensure that my image is signed before I push it. And even if the registry is not trustable, at least I can ensure that my image is trustable.
Yeah, I think that answers it in the right terms, and he was asking. Yeah, to add to that, yes, the previous legacy Notary tooling had inbuilt integration with Docker CLI, such that when you pushed images, it would generate signatures. But it also relied on registries having support for additional server-side components, which was not supported broadly in all public registries. Whereas Notary Project is just built on top of OCI specifications, which means you can use it with any registry without having the registry operators having to do any additional work. So the adoption is easier.
When did the Notary Project get rebooted and to be the specification instead of the legacy client server?
I think it's been around I would say two and a half years, where from the time we started working on the new set of specifications and set a new direction.
Yeah, I believe end of 2019. At least that's my...
Yeah.
Yeah, it's more actually. It's becoming almost 3 years now.
Yeah.
Wow.
Nice.
All right, revocation. I signed something and I take it back. I don't want it to be signed by me anymore.
Sure. So
what do I do?
Let's talk about this. So at a high level, two scenarios: revoking an identity and revoking a signature.
Okay, let's talk about revoking an identity.
So in the example that we were talking about, right, I am signing images. My public key, private key pair got compromised, or in real terms. So I'm following good practices. I'm storing my keys in the HSM and doing all of that. My access to the HSM got compromised. That's generally how it happens these days. Is like in those cases, I want to tell the world that no longer trust these public keys that I had previously created, or no longer trust my certificate. And that is revoking an identity. And the revoking artifact or a signature is I generated a signature and I distributed it. But say I discovered a CV in it, or I built something which is no longer fit in some way, and I want to indicate that. So you can revoke, for example, a single signature. Like these are, for example, some of the capabilities you can get with revocation. So the second would be like revoking a signature.
Okay.
The way you can think about that, Whitney, is like I have like my private key that I use to sign every individual image that I built, right? And let's say I built 5 images and they are signed with my private key. So if I revoke my identity, right, all these 5 images become untrustable because I don't trust that identity anymore. If I want to actually invalidate only one of those 5 images, I can revoke a single signature. And that's what our signature specification and the revocation flow allows you to do, which means that if, let's say, one example is, and I'll revert back to the famous SolarWinds example, right? So SolarWinds have been signing their software for years with the same identity, right? And let's say, imagine that they publish new version of their software every month. So for 2 years, they sign with the same identity. Every month, they publish a new version of their software, and which means you have 24 versions signed with the same identity. However, they discovered that between March and April, their kind of signing infrastructure got compromised. So they won't actually invalidate only 2 of those pieces of software and keep the other 22 still valid.
Okay.
That's kind of the second example where they revoke just a single signature and say, don't use this piece of software, use the May version of our software.
Yeah, that makes sense. And then, so with the Notary Project specifications, we support more traditional ways of doing it. These are called like CRL, OCSP checks. We won't get into the details of that, but basically it supports existing certificate authority-based mechanisms. And through the plugins, we'll talk about plugins, it also supports other ways of doing it. And I'll talk about an example of that, which allows you to like use newer mechanisms or specialized mechanisms. But the takeaway I would say is we feel that revocation is an important security control, easy to sign and get started and distribute artifacts. But it is very important to have a mechanism to deal with security incidents as well. We already have that built into this tooling with revocation support. And to contrast with, for example, with Sigstore, the process of generating signatures is simple. They don't have a similar revocation story. For example, in Sigstore, if you revoke, you need each consumer to know the identity that was revoked, and they have to set it up in their policy. So what it is, if you are a Sigstore consumer, in your verification policy, you would set up a deny list of who I don't trust. And you have to discover that who you don't trust. You would look at like CVE bulletins or other mechanisms, right? These are manual mechanisms. Whereas with notations revocation support, you're just relying on these automated mechanisms where a publisher can revoke something and then the consumers can automatically discover that and their verification would fail. So no additional action required by consumers.
Yeah.
Know
It
about
sounds like a pretty manual process for Sigstore. Yeah.
And the other thing is also the granularity of revocation, right? Once again, if I revoke identity, I revoke everything that is signed by this identity. And I just want to revoke just one piece of software and not everything that is signed.
Yeah.
I'm going to say hi to Fuel Snobble. Hi, Fuel Snobble. Fuel Snobble is a regular. Fuel Snobble was a guest talking about incident management. So it's funny that security incident came up when they said hello. Hello. Yeah, there's a lot today. It's pretty exciting. It's fun.
And I think this is a good point to, before we get into extensibility, touch upon like comparison between some of the technologies like Sigstore versus Notary Project. So we said at a high level, Sigstore is more apt for open source projects. It has signature transparency log record,
Mm-hmm.
where you have the identities, metadata, attestations being published to a public log, and you can easily discover that information. You can monitor that, so there's transparency and observability, which works great for open source projects. uh, but if you want, for example, revocation control, we have
Mm-hmm.
better end-to-end story there. If you are an organization or enterprise which has specific security requirements around where your keys should be stored, how they should be managed, integration with existing PKI infrastructure that you have already set up and which are already compliant.
Mm-hmm.
Other aspects being, some of these are again compliance related, like privacy of information. You don't want your internal identities and attestations being published to a public transparency log,
Mm-hmm.
or say data residency compliance or data retention compliance. In all of those places, like organizations want strict control over where the data is, how long it is maintained, in which regions they are maintained. And
Mm-hmm.
those may be reasons why you may not want your signatures to be published to a public log. And that is where, yeah.
Yeah, and to add to that is like I think we mentioned in the past air gap environments. So air gap environments, they may not actually have access to public law, right? How
Mm-hmm.
do you verify if you actually cannot access internet? Those are
This
important considerations when we work with enterprises, and that's how we designed Notary Project to evolve.
I love that. And I think it's something I would like to write down on the board, but I know you want to talk about extensibility. So I want to get extensibility on here first. And if we have a little space, I'd love to write. I think you gave like 4 good reasons why Notary might be good for your
Yeah,
use
yeah.
case.
I think we have enough space for extensibility. We can cover this right now, and then a little space for extensibility is okay.
Okay, so maybe we'll call this like benefits of Notary or like what distinguishes Notary? What's
Yeah,
I would call it
like
benefit.
trade-offs, you could say, or like yeah, I
all
think
right,
trade-offs or things to
benefits.
consider, I would say, like when making the choice, right? Yeah.
Okay, I'm just gonna go with benefits. So,
Yeah.
um,
So
yeah,
one
give
would
it to
be
me.
revocation control.
I just is it a C and not a K?
I
It's
think
a
see.
it's
Is
a
it?
It's C?
C. I think it's a
Okay.
funny one where if you say revoke, it is a K, and when you say
Yeah.
revocation, it is a C.
It's
I
it's
missed
uh
that
it's
actually.
we live in a world with spell check, so it's weird to do this handwritten board and really challenge what I
I'm
my
surprised that
spelling.
actually your handwriting is so good. I am
Ah, thank
amazed.
you. Thanks. I don't know. All right, so revocation control,
I
that's
think
awesome.
second is privacy.
Um, okay, privacy.
Yeah, I would say
So
signature privacy,
yeah, probably
privacy
done
of
better.
signatures. Yeah, either ways you can. Signature and attestation privacy.
That's a good point because, like, for example, some enterprises may want to add additional attestations to their images that don't need to be visible. We have like customers asking us, like, I would like to add, for example, the team that owns this image within enterprise. So, but I don't
Mm,
want to expose this information to the outside world. So, if
yeah.
publish every attestation to a public log, then
Mm-hmm.
the emails of my team may show up there or
Yeah.
things
Yeah,
like that.
totally. Like for example, SBOM, what is the set of dependencies?
Mm-hmm.
Makes sense to publish it if you are publishing public software. But like provenance information on what it was built, which server, what software versions internally were used, or internal identities, machine identities, and people identities, you don't want to publish them.
And
Yeah.
keep in mind that such information may be used for attacks, right? So if I have knowledge of internal infrastructure of somebody, I may actually figure out a way to do it. So
Yeah,
publishing.
for example, you can know what exact version of softwares were used in a build environment, etc. Things like that. I think the other would be compliance, and under compliance, so privacy is one of the things, but I think under compliance is also like data retention and data residency. Those, I mean, a lot of this comes to enterprises and organizations have a variety of compliance needs. This is not even a exhaustive list, but the point is you are in full control of your data and how to manage that data. And like many of them would be related to how you are operating your registries.
So instead of saying data retention, I'll say full control of data.
Yeah.
And then Toddy said something about air gapped, right?
Yeah,
in put that here.
air gap environments where you don't have access to public infrastructure. And if, let's say, the validation requires access to external transparency log, those validations will fail because normally you restrict the environment to just the internal network.
I think Sixtor has a mode where you don't have to rely as well, but yeah, that you may gain something by doing the transparency log check.
Cool.
Yeah, I think we covered.
Extensibility.
Yeah, extensibility, and I think the benefits. One of the benefits is extensibility too. We'll talk about it.
Okay.
So
I'm listening.
yeah, so in terms of benefits, extensibility is mainly being able to integrate with your existing infrastructure that you may have already set up, operated, and
Yeah.
compliant internally, and you want to use those mechanisms.
Can I put existing estate?
Yeah.
It's a shorter word. It
but
fits.
also future. So we don't know what enterprises will use in the future. Like maybe Milind can speak because AWS Signer is a relatively kind of new service. Milind, correct me if I'm wrong. And able to very easily actually implement functionality to use AWS Signer to sign images with Notary Project signatures.
Yeah. So yeah, when we get into signing extensibility, I'll give examples of how AWS Signer provides managed signing, which is easier than managing your own keys and certificates. So kind of similar to Sixtor, where you don't have to worry about keys and certificates. I'll talk about that a bit. So extensibility. So the notation tooling has a plugin model, and you can write plugins for signing and verification. We'll talk about signing plugins. So signing plugins allows you to integrate with existing signing infrastructure, third-party key management services, or cloud service provider based solutions. So it gives you this extensibility hook. So for signing, core of which is where is your private key stored and how the signing operation occurs. Uh, that can be defined by you. And notation will take care of all of the other details, which is the signature format, packaging it, and pushing the signature to the registry. But you can offload this core signing operation to whatever you want. And that allows you to use your existing infrastructure or a third party solution that you have been already using.
So
And
signing plugins help you integrate with third-party key management and the core signing operation tools.
for the core signing operation. Yeah. So your core signing operation is done by this third party
Key management.
management.
So could I say the signing plugins help you integrate with third-party key management and leave it
Yeah.
at that?
Yeah.
Okay. Cool.
So we have a few implementations here. We have Azure Key Vault integration. We have HashiCorp integration, I think, in the works. Toddy can correct me there.
Yes. Mhm.
And we have AWS Signer integration, and I'll talk a little bit more about AWS Signer integration as a. So we talked about you can integrate with existing infrastructure, and with AWS Signer, it's an example of something that is allows you better manage signing. So with AWS Signer, for example, you set up an identity. You don't have to
Mm-hmm.
create keys or PKIs, and you just configure this identity. And with the plugin, it calls AWS Signer based APIs, and AWS Signer will generate signatures. Uh, so it is, and it's a free managed signing solution. Uh,
Uh-huh.
so it like provides similar benefits to say like with Sigstore, you don't have to manage keys and PKIs. You can
Uh-huh.
implement those kind of models as well.
Excellent.
And we
Cool.
define, so we have specifications here. So we talked about notation has this plugin mechanism, and we have specifications that will allow you to implement your own plugins. So we publish the contract, and we have a few examples, and you can integrate with any of your own solutions as well.
So besides signing plugins, you want me to just put in make your own plugins, BYO plugins?
Yeah, you can bring your own plugins uh, based on your, if you have a need to integrate with your signing infrastructure.
Cool. Is there anything else with extensibility?
Not with signing. Toddy, is there anything you want to add on signing?
No, I think that's all. Mhm.
Okay, and then we have verification plugins.
I started writing too big. I thought this was the end. Okay. Infrastructure. Wait. What was it? Plugins?
It's
Identity?
verification plugins.
Verification. Oh, yes, of course. Okay.
So verification plugins allow you to extend some pieces of verification logic. I want to be clear on both of these. So these plugins are implemented in a way that doesn't undermine the security values of notation or Notary Project specification. Uh,
Mm-hmm.
the the notation tooling strictly controls the inputs and outputs. We have put a lot of thought into what data is actually provided to the plugin versus what is controlled and
Mm-hmm.
not shared with the plugin. So for example, with verification plugin, Notation doesn't fully trust the plugin. Notation does its own signature verifications and tells the plugin, here, I've done all these basic verifications that I do, and
Mm-hmm.
you can do additional verification if you want. And I'll give you
Uh-huh.
examples of it. So AWS Signer has a verification plugin which integrates with revocation checks. AWS Signer has a custom revocation checks that allows you to do both identity revocation and signature revocation. So, for example, if you use a CA-based certificate authority, they generally
Mm-hmm.
only support revoking a certificate or an identity. Uh, but with AWS Signer's revocation plugin, as an example, you can do signature revocation as well. Another thing would be, like, for example, all AWS services have regional endpoints. So you don't
Mm-hmm.
cross-region dependencies, etc. So you have, for revocation checks, you can make in-region calls rather than cross-region calls, which may have
Oh,
availability and latency concerns.
ah,
So
okay.
basically, what it means is you can you can customize this the verification workflow, or extend the verification workflow to your specific needs. For example, you may have a transparency log hosted in your organization
Mm-hmm.
using some open source technology or your own custom technology. And as part
Mm-hmm.
of signature verification, you want to check that this signature does exist in my transparency log. You can do that
Mm-hmm.
with verification plugins. So those are like some of the scenarios and like actual examples of how we use verification plugin. The takeaway again
Cool.
is we have built base set of features, and we have given extensibility points where you can customize to your workflows and your processes.
Yeah,
And
excellent.
there's one more topic which again is under extensibility.
Mm-hmm.
We're running out of space there, so I'll just mention it.
Mm-hmm.
Before that, Toddy, do you want to add anything more on the plugins topic?
No, you covered it well. Thanks.
All right. So, and this is again for, so all of the extensibility part is for integrators. These are not like directly visible to end users. End users will see benefits in their experience, uh, but these are like details for integrators to integrate with notation. So we have the notation CLI, that the tooling that you can use to sign and verify, but we also have libraries that third parties can use and directly integrate in their workflows. And
Is
yeah,
is libraries are the libraries considered part of the notation? Part of notation?
yeah, the libraries are managed under this. So notation is a reference implementation uh,
Mm-hmm.
managed by Notary Project, maintained by
Mm-hmm.
Notary Project, and composes of CLI and libraries.
Mm-hmm. Cool. Thanks.
And then the other part about extensibility is called signing schemes. And this generally means there are some trust models that uh, notation implements, and
Mm-hmm.
have some flexibility around implementing newer types of trust models. And I'll give you a quick example of this. Like with traditional signing, you have CAs, certificate authorities, and you
Mm-hmm.
have entities. Like in an example, like I came to you and say, "Hey, issue me a certificate, and here's how you can
Mm-hmm.
trust me," right? And I sign it. I have my own keys, or I'm using a KMS or a third-party solution, Key Vault, etc. There are other trust models, for example, as a signing authority, not a certificate authority, a signing authority, which is a signing service. So the AWS Signer implementation is a signing authority, which means I go to AWS Signer, I trust AWS Signer, and I create an identity in it. And anybody that wants to consume the signatures also trusts AWS Signer.
Mm-hmm.
So the trust model in that is a little different. So AWS Signer manages the key PKI and generates the signature. And we wanted to implement that kind of a trust model, which has certain customer benefits of you don't have to manage anything. So we
Mm-hmm.
so we implemented that through signing scheme, which is again an extensibility point for implementing different trust models.
Mm-hmm.
That can be again, uh, this is an open community, and we we welcome other ideas on implementing different types of models, like um, tough or ledger based, transparency log based, and like other models can be implemented using the same extensibility mechanism. And this is for like
Mm-hmm.
integrators and community to be able to extend this tooling as there are improvements made in this area.
Mm-hmm. That makes a lot of sense. So you don't have to do another reboot again later down the line.
Right. Yeah,
It should be
totally.
able to
Like
grow with
it
you.
all can be supported under the same umbrella and you don't have to reboot. Like the customer experience can remain pretty much similar, but you can change the plumbing inside.
That's wonderful. This has been really great. We've covered a lot this morning, huh? If you feel like you've said everything, you've taught me everything that you wanted to, then I'm going to do a recap and go over everything that we talked about this morning and make sure I have a good understanding, or that
Yeah,
we
I think
do.
we're out of space, but I think there's a
Uh-huh.
little bit about uh, verification in Kubernetes environments. I see a
Uh-huh.
small rectangle there in between where, where your head is. I think we could use that.
Oh, will this cover my face? Sure. I don't, who needs to look through anything? I
Toddy,
can kind of peek over here.
you want to
Yeah.
talk about the integrations we have with Kubernetes?
Yeah, so they are actually, and very briefly around that. So on the verification side, and we just talk about the libraries. So there are two admission controllers that right now integrate with Notary Project signatures. One is Kyverno. So Kyverno already has implementation that they can verify Notary Project signatures before you deploy to AKS clusters. And the other one is Ratify, which is based on works together with Gatekeeper. And Gatekeeper has integration that through Ratify can go and verify also Notary Project signature. So the benefit of this is, like, if you, for example, you want to create policies for your Kubernetes clusters to say, look, for certain deployments, I want to trust Notary Project signatures, and for this application, I trust these signatures. For that application, I trust that signature. You can go and do that right now using Kyverno and Ratify. So you need to deploy the Kyverno and Ratify workloads on Kubernetes, but you can secure your Kubernetes cluster with Notary Project signatures.
So there are two Kubernetes admission controllers that you can use to verify notary signatures. One's a Kyverno admission controller, and one's an OPA Gatekeeper admission controller.
Yeah. OPA Gatekeeper has a data provider called Ratify, which is
Okay.
open source project. So Ratify is the actual piece of software that does the evaluation of the policy.
Ratify. Excellent. Cool.
And in
Ratify has this, Toddy can correct me, validator model. It can support different types of artifacts. Like, so Ratify's job really is, given an image, and you can have multiple things associated with that image. We talked about OCI specifications enabling that. So you can have signatures, you can have signed SBOMs, you can have CV scan results, and in Ratify is it's kind of routing those. It's saying, if it's a notary signature, handle it this way. So it has inbuilt notation integration. So it will say, this is a signature type, verify it. And you can specify your notation trust policy within Ratify configuration. Or you can extend Ratify by saying, okay, this is a SBOM. I want this tooling to validate the SBOM or validate this CVE scan. So Ratify is where you can centrally define how you want to handle all these pieces of metadata associated with the image.
Yep.
Awesome. This has been so informative. Kormaju said lots to learn. This is an amazing session. Thanks,
Cool.
Whitney, Milland, and Toddy. Yeah.
Thank you.
So I'm gonna go from behind my wall of text. I'm gonna do a recap. So before Notary, I don't know where to stand. Before Notary Project existed, folks had a hard time knowing where their container image came from and knowing for sure. So that's authenticity, I know now. And then knowing that it hasn't been tampered with. So knowing that the integrity. And then there's also adoption problems with early signing tooling because it could be difficult to use. So Notary Project is a specification that defines how a signature is created. There's also specifications around verification and specifications around extensibility. Notation is the Notary Project's supported implementation of this specification, but other tools can implement it too. And then notation's implementation of the specification is a CLI tool, or it can be libraries. Now, before I started this session, what I knew of Notary was the legacy version, which is a legacy client server with which you can sign images. And that's, a lot of people use it, so it's being kept in it still is supported, it sounds like, but it's not, but Notary these days has to do with this specification. So what does it mean to trust an artifact? So there are two main things: integrity and authenticity. So authenticity is like you trust the source that made the artifact, or really the source that wrote the attestation that said they made the artifact. And then integrity is that you can tell it hasn't been tampered with since that authenticity was produced. We talked about how artifacts are everywhere: base images, app images, supporting service images, images made in-house, images made in third parties, SBOM artifacts. It doesn't necessarily have to be container images. And so signatures help ensure that all of these artifacts are not compromised, even if the sources and systems do get compromised. Also, these images, as they go through software supply chains, are going to change and move and go all over the place. And so we have systems, tools, processes. There's signatures happening at every step if anything's modified, but also the signatures from previous steps are traveling with the artifacts as they move through a software supply chain. So at any point, you should be able to trust what's running, what's happening in the system. So it's not just an end, like what's running in production. It's like what's running any point, any step of the way. We touched on the software supply chain generally: code, system, tools, process, everything that touches your application, your whole process of development and deployment of your application. It's a big and vast and hairy thing, a software supply chain. It can get very complex. So for background, we talked about attestations. So attestations are signed statements at a point in time. So it might be like, I built this image. That could be an attestation, and then I sign it with me. It could be, here's a software bill of materials of this image. That could be an attestation. Here's a vulnerability report. That is an attestation. But it represents the state at the moment that attestation was created. But that state is likely to change if we're talking about like an SBOM or a vulnerability report. And so for that reason, attestations can be appended with new information as it's discovered. So it's a great example would be as if a CVE is found. So an attestation is basically rich metadata. And when a signature happens, the signature is happening to the attestation. Is that correct?
You're signing the attestations,
Yeah, so that's why it's like you're not signing the artifact that the artifact is trusted. We're signing the attestation that whoever said the thing about the artifact is like the person who said that thing is the person who you think they are.
Yeah,
but
and the attestation will have a reference to what artifact is referred here. So yeah.
Okay, that makes a lot of sense too. So we talked about signing an image. So when an image is signed, it's the hash that's signed, and it's signed with a private key, and it's verified with a public key. So we're talking about classic PKI, private key infrastructure here. A certificate is a signed public key. So that's, as a newbie, that was a very confusing thing because public key and private key are can you still hear me?
Yeah.
I think my headphones are sad.
Yeah, we can hear.
Okay. It's signed by someone I trust. I'm just gonna charge one earbud while the other ones. Will you talk to me?
Yeah, I can hear you.
Okay, cool.
Mm-hmm.
So it's signed by someone I trust. So Notary Project, we talked about how it's a specification. There's a specification for how to create a signature. So there are three parts to that. It's like how to generate the signature itself, the signature format, and then the encryption standard. And that's part of what Notary Project is. So then those notary signatures are stored alongside the artifacts, and they can be used in the verification process. And then, as I mentioned already, those signatures will move with the artifacts as they moved around to different registries. And then we talked about signing formats, which has more to do with the integrity, that it hasn't been tampered with. Is that correct?
So it is just how you represent these signatures, and there are multiple formats for that.
Okay, so those formats can be, the most common is called JWS, which stands for JSON Web Signatures, which is a JSON format. But then there's a newer format called COSI. What did he? COSI, yeah, Mervyn COSI, which is CBOR Object Signing and Encryption. But basically, that one's a binary format, and therefore it's a lower compute to use, and so it's widely used in Internet of Things or edge devices and anything that's low power. And Notary supports both of those signing formats. And then we move on to verification. So now we need to verify the signatures. And so by default, notation, the tool notation, trusts nothing at all. So if you try to verify anything with notation, and when it's coming right out of the box, everything will fail because you haven't taught it to trust anything yet. So you use a trust policy to tell the notation tool what you trust. And so you specify two things in this trust policy. You specify a trust root, which has to do with who issued the certificate, which is like a certificate authority. And you also specify the identity of who signed it. So this is more of like an individual thing, like a person or a machine or whatever, a process. That helps to, so then we have verification levels that you can use. So strict, permissive, audit, and skip. And those are important because it helps you, if you want to start using signatures in your system, if you just turn it all on at once, it's going to break a lot of things. So you have these different verification levels, so you can slowly and incrementally adopt how your company adopt signatures, and eventually get everything to where you can do strict adoption, ideally. Probably,
Yeah.
And so that's how verification works, and also how you would onboard signatures, which is fascinating. And then we have a problem that I didn't know existed before today, which is, what if an identity or a source gets compromised? So how do you revoke a signature once it happens, once a compromise happens? So what's cool about Notary Notation and Notary Project is that there's some granularity involved with how you would revoke a signature. So you could revoke an identity, which is where any signature made by a whole, like a certificate authority, is no longer trusted. So tell the world, hey, don't trust anything made by this certificate authority. Or you can resist. Sorry.
The certificate authority or an identity itself.
Or an identity. Okay. Or you could, yes. Okay. Got it. Or an identity. And then, or you could revoke an entire signature. Just a signature. So if an identity made 5 different images, and you say this identity is bad news, all 5 of these are bad, then it would go away. Or if only one of those images got compromised because the vulnerability only happened at a certain point in time, then you can revoke just the one image. So you have granularity, you have control over how that happens. And it's an important part of security control, because it would suck if you have to take away every single thing for just one problem. So then we talked about, I'm going to say benefits for last. So then we talked about extensibility. So we talked about Notary Project has specifications for verification, and now it also has specification for extendability with plugins. So with plugins, you can Notary can do bigger and better things. So you can use signing plugins so that your Notary implementation can integrate with third-party key management. A legacy version used to do a key management, but now we've taken that out because there's other tools that do it well. There's no need to reinvent the wheel. You can bring your own plugins that help you integrate with whatever your particular signing infrastructure looks like at your organization. There are verification plugins if you want to extend the verification logic and do something maybe more strict than what comes out of the box with Notary Project. There's also trust model plugins. So if the world figures out a better way to do security, Notary should be able to grow and encompass that instead of having to do the reboot that y'all had to do about 3 or 4 years ago. So now it's designed to grow as security models grow and change. So I think that's everything. Is that, oh, we talked about integration with Kubernetes too. So the policy agents and projects in Kubernetes, the two very most popular ones are Kyverno and OPA Gatekeeper. And so both of them integrates with Notary and have ways to verify Notary signatures. And I think that's all. How do you feel? Is there anything else that you'd like to add?
Yeah, and then I think that was the recap of the benefits that you wanted to go ahead.
Oh, yes. That's freaking. I was saving the best for last, and then I almost forgot the best. So the benefits of Notary, you have revocation control, which is very important, and not other signing tools don't necessarily have that. You can integrate well with your existing estates. And I'm going to expand that to say, as security models grow, this is meant to grow with it. You have signature and attestation privacy. So Sigstore in particular publishes to a public log, which could be problematic. So it's not published to a public log. That's also going to help with compliance, where you have full control of your data and where it is. And that's also going to help with the fact that if you want to use it in an air-gapped environment, you might not be able to access that public log. Yeah. And that's Notary.
Cool. That was a good summarization.
Yeah, that was actually great summarization. So,
well, thank you for that. Means you taught me well. We have a this might be the most full board yet. I have to agree with you. This is it's like, where'd Whitney go? I can hear her, but I can't see her. I'm really, really happy with this. This has been really fun, and I've learned so much.
Thank you, Whitney. It was fun for us too. We really appreciate
it. Wonderful.
Yeah. This was a great experience, and I think your format also works great in terms of like starting with the basics and building on, and like the summarization at the end.
Mm-hmm.
Wonderful. Thank you. I warned you at the beginning, but the way we say goodbye to everyone here is by doing a little dance. Don't feel like you have to move your body too much. You can use this, whatever. I'm going to dance though. Yeah, here we go to say our goodbyes.
We cannot see you, Whitney.
All right. Thank you, everyone. Bye.